Hello and welcome to this next lecture on fundamentals of acoustics. We are looking at interior acoustics or interior sound fields. In a rigid cylinder. And we had used separation of variables then found that along the radius it's Jm kr phi of r, along the phi direction it's E cos m phi plus f sin m phi, along the z direction it's cos q pi by L z, along the time it is A cos omega t plus B sin omega t. Okay. But now the finiteness of the cylinder has brought in an eigenvalue problem, and therefore there are many eigenvalues and eigenfunctions, many natural frequencies and mode shapes. Okay, this is what we call eigenvalues. In a different language, eigenvalues, eigenfunctions. Okay. So then what happens, in the r direction we have Jm, but we have k r phi but with an mn index. Of course phi, along the phi it remains the same, E cos m phi plus f sin m phi. So this m and that m are same, and along the z of course again it remains the same. You get a q index, q pi z. But as a result of this we saw we got k square mnq is equal to k square zq plus kmn r phi squared. So this results in omega mnq, the radian natural frequency. So my time now becomes A cos omega mnq t plus B sin omega mnq t. Okay. With this what we are looking at is response to initial conditions. Okay. Boundary conditions have been established. Boundary conditions have given me the mode shapes and natural or resonant frequencies, natural frequencies omega mnq. Okay, and no forcing, no exterior forcing, no exterior forcing. It is homogeneous response. Homogeneous. Okay, so what now is the mode shape? The mode shape looks like this, or rather the total pressure is like this: P R comma phi comma Z comma T is equal to summation M N Q A M N Q J M K M N R phi of R cos of Q pi Z by L E cos M phi plus F sin M phi cos omega M N Q T. Okay. So, these are spatial terms and this is the temporal term. And the next other term is summation over M N Q B M N Q J M K M N R phi of R cos Q pi Z by L E cos M phi plus F sin M phi sin omega M N Q T. Okay. So, now what are the unknowns? The unknowns are this A M N Q and E combination, then A M N Q and F combination. Okay. Similarly, B M N Q and E combination and B M N Q and F combination. Okay. We have to figure this out from initial conditions. So, let us see, let us say T equal to 0. Let us say the pressure at R comma phi comma Z comma T equal to 0 is some P star function of space. Okay. Then time t equal to 0, this term is 0 and this term is 1. Okay. So, I will have only this term survive. So, what I will do is I will take an integral 0 to L 0 to 2 pi. Okay. The idea is to use now orthogonality of these functions. Okay. So, I will do P star, which is a function of space, multiply by a cos V pi Z by L and a sine of, let us say, S phi plus theta and dz and r d phi. Okay. Now, the idea here is, in order to find the E and AMNQ combination, multiply by a certain cos S phi, use orthogonality and figure out AMNQ and E, that is all. Similarly, to find AMNQ and F combination, multiply by some sine S phi, integrate over 2 pi and find using orthogonality. Okay, it's as simple as that. I am just combining the two. Here later I will put theta equal to 0, which will make it a sine S phi combination, and I will then put theta equal to pi by 2, which will give me a cos S phi. that is all. Okay, I am just shortening the steps over here. Okay, if this is the left hand side, what do I have on the right hand side? I have integral 0 to L, integral 0 to 2 pi summation over m n q a m n q j m k m n r phi of r cos of q pi z by L cos of v pi z by L into E cos m phi plus f sin m phi into sin s phi plus theta dz r d phi. Okay. Now, let us look at 0 to 2 pi, this which has phi in it and this which has phi in it. Let us look at that integral. So, what do I have? I have integral 0 to 2 pi E cos m phi plus f sin m phi sin s phi plus theta d phi. Okay. Now, for m equal to 0 we have one calculation, m not equal to 0 we will have another, that is the catch over here. So, for m equal to 0 I have integral 0 to 2 pi, then I have only E surviving, I have sin s phi plus theta d phi, okay, which is equal to what? Integral 0 to 2 pi E sin s phi cos theta plus E cos s phi sin theta d phi, okay, which is 0 unless s is 0, s equal to 0, okay. And if s equal to 0, then this is equal to E 2 pi sin theta for s equal to 0. That means s equal to 0 is equal to m for m equal to 0. Okay. Now, that is one part of the story. When m is not equal to 0, I have integral 0 to 2 pi E cos m phi plus f sin m phi and sin s phi cos theta plus cos s phi sin theta d phi. If I open this out, I have integral 0 to 2 pi E cos m phi sin s phi cos theta plus E cos m phi cos s phi sin theta plus f sin m phi sin s phi cos theta plus f sin m phi cos s phi sin theta d phi. Okay. Now this part is 0 anyway, this term is 0 anyway, okay, because you have a cos and a sin. Whatever happens to m and s, this is orthogonal, they will be 0. But here if m equal to s, then this term will survive. Similarly, if m equal to s, this term will survive, whereas again this term does not survive whatever happens, because you have a sine and a cos over 0 to 2 pi. Okay. So now if m equal to s, then I have integral 0 to 2 pi e cos square m phi sin theta plus f sin square m phi cos theta d phi. Okay. Then this is 1 plus cos 2 m phi over 2, cos 2 m phi integrates to 0 over 0 to 2 pi. This is 1 minus cos 2 m phi by 2, here also cos 2 m phi integrates to 0. Okay. So I have half left over. Okay. So what happens is this results in e sin theta plus f cos theta into a pi, the 2 pi divided by 2, and this is for m not equal to 0, and we have e 2 pi sin theta for m equal to 0. Okay. Now if we start again, let us see, we have an integral over 0 to L, integral 0 to 2 pi on the left, p star cos v pi z by L sin, now m phi, because m and s have to be same, dz d phi into r. On the right I have, okay, for m equal to 0, integral over 0 to L summation, now only nq, a with an m0 nq, j with an m0, k with a 0 n r phi r cos of q pi z by L cos of v pi z by L. Then what we found, e into 2 pi into sin theta into dz into r, whereas for m not equal to 0, we have integral 0 to L summation again n q, this time a m n q for a particular m, j particular m, k m n, r phi of r cos q pi z by L cos v pi z by L into e sin theta plus f cos theta into pi into dz into r. Now if we have 0 to L cos q pi z by L into cos v pi z by L, q and v going from 1 to infinity, then this is 0 when q is not equal to v, and this is equal to L by 2 when q is equal to v, and I will give this a symbol gamma qv for now. That is L by 2. Okay. So now if that integral is also performed, what do I get? I get this, okay, is equal to summation, only our n now, because v and q are selected, q j0 k0 n r phi of r gamma qv twice pi e sin theta into r. This is for m equal to 0, and it is equal to summation over now n a m n q particular j m k m n r phi of r gamma q v e sin theta plus f cos theta pi into r when m is not equal to 0. Okay. Now here we need the Bessel function orthogonality. And we are having a cylinder which is rigid. Okay, it is rigid at the z ends and it is rigid at the wall also. Okay. So now if we look at a Bessel function derivative, okay, lambda m n, okay, these are lambda m n are the roots or values where the derivative of the Bessel function goes to 0. Okay. So if we have a j0 Bessel function, let us say, it behaves, oscillates like this. So this is first time it goes, derivative goes to 0, second time the derivative goes to 0, third time, etc. Okay. So lambda mn are those values. Now if you look at them in a tabular form, and let us say I have m equal to 0, m equal to 1 and m equal to 2, and let us say n or n goes this way, and for first one, okay, we have j0 dash lambda, okay, that goes to 0 at 0, okay, lambda equal to 0. The second one, it goes to 0 at lambda equal to 3.8317, and the third time it goes to 0, lambda is 7.0156. Similarly, j1 dash of lambda, it goes to 0 first time at 1.8412, the next time at 5.3314 etc. And similarly J2 derivative goes to 0 at 3.0542, 6.7061. Okay. So now we have lambda m and n. Okay, these are lambda m n, lambda 01, lambda 02 etc. So we write this mn or phi into A is equal to lambda mn. This is one equality I introduced where A is the cylinder radius. Okay. So now what happens is we have Jm dash Kmn or phi into A is equal to 0. Okay. So these values are Kmn or phi into A values. So Kmn or phi will change based on the radius. Okay. And now the Bessel function orthogonality. Bessel function orthogonality with roots where this is valid, okay, is this integral 0 to A r Jm Kmn r phi into r J the same m Kmn star r phi into r a different n into dr is given by a square lambda mn square minus m square j m square lambda mn divided by twice lambda mn square delta n n star. Okay. So this and this, when they are 0, this is the value, else it is 0 if n is not equal to n star. Okay. For example, if we consider this value, okay, then from here, and let us say that A is 2, suppose A is equal to 2, then we will get for 1.8412 m is equal to 1. Okay. So we get a square 1.8412 square into 1.8412 square minus m square, m is 1, into j 1 square at 1.8412 divided by 2 into 1.8412 square. This is 0.4772. If we consider 5.3314 m equal to 1, we will get 0.2312. Okay. So this is the Bessel function orthogonality. Now what we have here is for m equal to 0, integral 0 to L integral 0 to twice pi p star cos q pi z by L sin theta dz or d phi, okay, that ended up as a summation only over n 0 n q j 0 k 0 n r phi r gamma q v twice pi e sin theta into r. If we add the a integral now, integral 0 to a, integral 0 to L, 0 to twice pi p star, okay, then j 0 k 0 n star r phi of r cos q pi z by L sin theta dz r d phi dr. Then on the right we get integral 0 to a summation over n a 0 n q j 0 k 0 n r phi of r j 0 k 0 n star r phi of r twice pi e sin theta r dr. Okay. Now let me just, I want to give this a symbol. The symbol is b m a lambda m n. Okay. It is of order m, so that bm, it also depends on a, therefore a, and it depends on lambda mn, therefore lambda mn. Okay. So this is the symbol I will give instead of writing this every time. Okay. So now here this becomes equal to a 0 n q b 0 a comma lambda 0 n gamma q v twice pi e sin theta. Okay. And for m not equal to 0, integral 0 to L, integral 0 to pi 0 to 2 pi p star cos q pi z by L, because q is v, sin m phi plus theta dz r d phi. This is what we had, and that ended up as summation over n a m n q j m k m n r phi of r gamma q v e sin theta plus f cos theta into pi into r. Okay. Then we do the same step, bring in 0 to a integral. So we have 0 to a, 0 to L, 0 to twice pi p star j m k m n star r phi of r cos q pi z by L sin m phi plus theta dz d phi r dr, that is equal to, now the orthogonality takes out the n summation b m depending on a and lambda mn gamma q v e sin theta plus f cos theta into pi. So, now we have everything we need. When theta equal to pi by 2 and m equal to 0, then a 0 and q into e, this into this is the unknown, is given by integral 0 to a, integral 0 to L, integral 0 to 2 pi p star j 0 k 0 n r phi into r cos q pi z by L dz d phi r dr divided by the constants that arise b 0 a comma lambda 0 n gamma q v, which is actually L by 2, and twice pi because m is 0. Then when theta becomes equal to pi by 2 and m is now not equal to 0, a m n q e becomes integral 0 to a, 0 to L, 0 to twice pi p star j m k m n r phi r cos q pi z by L cos m phi dz d phi r dr divided by b m a comma lambda m n gamma q v into pi. And lastly, when theta equal to 0, m not equal to 0, a m n q into f is equal to integral 0 to a, integral 0 to L, 0 to twice pi p star j m k m n r phi r cos q pi z by L, this time sin m phi dz d phi r dr divided by b m a comma lambda m n gamma q v into pi. Okay. So, finally what happens? The pressure r comma phi comma z comma t is the 0th term, m0 term, j0 k0 n r phi of r cos q pi z by L cos omega 0 n q t plus summation over m running from 1 to infinity summation over n running from 1 to infinity, summation q 1 to infinity a mn q e cos m phi j m k mn or phi r cos q pi z by L cos omega mn q t plus summation m 1 to infinity summation n 1 to infinity summation q 1 to infinity a mn q into f sin m phi j m k mn r phi r cos q pi z by L cos omega mn q t, and the bmnq terms which we never so far discussed. It is very similar. Jm k mn r phi r same cos q pi z by L e cos m phi plus f sin m phi, but sin omega mn q t. So, in order to find the bmnqs, if we have this information at time t equal to 0, p dot temporal derivative r phi z at t equal to 0 is some p dot star, then p dot star. Okay. So, that means what, the derivative ends up as cosine at time t equal to 0, it survives, whereas these terms become sine and they do not survive, and an extra omega mn q comes in front. So, p dot star is given by summation mn q omega mn q b mn q, okay, the Bessel term, the cosine term, the phi term, okay, and now the same orthogonality one by one with special m0 calculations, they are separate, will get you b mn q. Okay. So, what we have seen, this is a response to initial conditions, okay, initial condition response, where the boundary conditions are homogeneous. And no forcing from inside the cylinder, no other forcing from inside the cylinder. Okay, that is the story. I will close the lecture here. Thank you.